Okay, today's lesson is the last lesson before spring break. We are continuing our graphing of the sine and cosine functions. We're going to pick up with what we did yesterday, finding amplitude and period length. But this time, today, we're going to do it without graphing, so we don't need to look at the graph to know these things. Then we're going to talk about vertical and horizontal shifts. In trigonometry, a horizontal shift is frequently referred to as a phase shift. And for those, we are going to just be graphing. Well, the vertical shift, you don't really need to use a graph, but phase shift is a little more complex. We're not going to get into the complexities today. So the notes as we do it, you'll see there's sort of two halves. The upper is going to be amplitude and period length without graphing. So essentially we have two forms that we can see, one sine, one cosine. You can have a coefficient in front of sine and a coefficient in front of x, or a coefficient in front of cosine, a coefficient in front of x. The one in front of the sine or cosine is almost always referred to as a, which is very helpful because a, well, the absolute value of a is the amplitude, which obviously begins with an a. Now, if that coefficient there happens to be a negative, if you're talking about amplitude, you just disregard the negative. That's why there's absolute value bars there. To find the period length, that involves b, but it's not simple, like a is the amplitude. B is not the period length. B gets plugged into a little formula, and then that gives you the period length. So that formula is 2 pi divided by b. So as we go through the first half, that's what we're going to talk about. The amplitude just being a, the period length being a calculation you can do using that formula. And then I'll get to the second half in a minute. So here, well, before I begin, let me write this down again. Period length equals 2 pi over b. That's our formula. Amplitude, the number in front of sine, there is no number, which makes it 1. And remember, everything has a coefficient of at least of 1. For the period length, the b value is 4. Here, let me do it this way. B is 4, so the period length is 2 pi divided by 4. That, as a fraction, can be reduced to 1 pi over 2, and that's our period length. Amplitude 1, period length pi over 2, and we did not have to graph it to get those answers. Let me scroll down really quick and look at answer number 2, and there it is. Amplitude 1, period length pi over 2. Let's look at the next one, again without graphing. Amplitude, simple, 5. That's all there is to it. Period length, 2 pi over b. But in this context, it might be a little unclear. What is b? We're looking at theta over 6. Remember, theta is our x, same thing. Theta over 6. Well, dividing by a number is equivalent to multiplying by a fraction. So theta over 6 is the same thing as 1/6 times theta. So our b value is 1/6. That means a 1/6 goes down here. So how do you divide 2 pi by 1/6? Well, throw back to 5th grade, 6th grade, whenever you learn dividing by fractions. But the rule is when you divide fractions, you keep the numerator, change this divide to times, and reciprocate or flip over the denominator. Keep, change, flip is the way it's taught a lot. So this becomes 12 pi over 1, but 12 pi over 1 is just 12 pi. So our amplitude is 5, our period length is 12 pi. Again, I'll scroll down to number 4 just to check it because, you know, sometimes mistakes. But nope, there it is, 5 and 12 pi. Let's do number 6. Amplitude, bam, right there. There's our a. Actually, it's lowercase a. There's our amplitude, 7. Period length is 2 pi over b. In this case, the b is a 1. So simply put, the period length is just 2 pi. 7 amplitude, 2 pi period length. And let's check. Number 6 right there, 7 and 2 pi. So the only difficulty might possibly be a situation like this. So if it's theta over a number, you have to do the whole keep, change, flip right here. But you do a few of those, you get the hang of it, it's no big deal. And you've got these notes to look at. Now, for phase shift and vertical shift, remember phase is horizontal shift. So, well here, let's look at number 8. If I just graph y equals cosine x. The wave looks like this. It starts at the point 0, 1, and it goes through one full cycle at 2 pi 1. And what we're going to look at now is a graph that's either been shifted up or down, and then left or right. So instead of having a wave that starts here, ends here, and does something like this, we might have a graph that starts here and goes like this. That's a shift up. Or maybe it also shifts to the right and it looks kind of like this. Or maybe it shifts to the left, or who knows. So that's the things we're looking at. As far as stating what the phase shift is, we'll get into that after break. So we're not going to worry about that right now. We're just going to let Desmos take care of that. The vertical shift is almost as easy as amplitude. So we'll go ahead and discuss that. That's why you see VS underneath the problem. Underneath all of these, you see a VS. That's going to be very easy. So let me delete this and go ahead and graph problem number 8. Y equals function cosine. Oh, by the way, I did make sure that I was in radians and my step, oops, I meant my step to be pi. So yeah, the graph is all set up. Okay, so x plus pi over 2, x plus pi over 2, and then outside here, minus 1. Now, I hope you can see that this wave is now shifted down. And the best thing to look for is that midline, the line that cuts horizontally through the middle. This midline cuts right through at -1. So this graph has shifted down, or down to -1. It has a vertical shift of -1. It is no coincidence that there is a -1 right there in the equation. So it turns out the vertical shift is always whatever the constant is outside of the parentheses. The one outside the parentheses is your vertical shift. So one thing you can do is go down to -1 and do a little dotted line if you like. You don't have to, but it might help you as you're graphing this. Now, we tend to graph things looking for key points. So 0, -1. Let me change colors. That is a y-intercept. Pi over 2, -2 is here. 3 pi over 2, 0 is right here. Let me see if I can trace this. Where is it? Right there. Pi comma -1. Doesn't really show up perfectly, but that's going to be on that line of oscillation, the dotted line that I drew. 5 pi over 2 down here. Again, there's sort of a line, a point right there at 2 pi. 2 pi is 6.3, -1, so right around here. And then 7 pi, oh, that's a little bit too far. But at 3 pi, again, we're at -1 right there. So we got our little curve like this, and then it switches to a curve like that, and then it switches again. So we got minimum, maximum, minimum. You can sort of draw little arrows here to indicate that you know that it's going on forever. But there's our graph. Now, again, a regular cosine graph starts here and goes down. So this has not only shifted down, but it's shifted to the left or to the right, and we can analyze that a lot, much later. But for now, just do your best to copy from the graphing calculator to paper and then indicate your vertical shift, and that's a fairly simple thing. Let's look at number 10. So can you tell what the vertical shift is going to be here just by looking at it? I'm going to go ahead and graph a regular sine wave. I'll be deleting this in a minute. And then I'm going to graph y equals sine of x. And then outside there, I'm going to put this +2. So I'm kind of ignoring that for just a minute. +2. And you can see that purple graph has been shifted up 2 units. So that +2 is a vertical shift up 2 units. So now I can delete this. That was just for perspective. And then on this one, I can do the +3 pi over 4. And now we get a much different looking graph. It has been horizontally shifted as well. So we need to try to draw this in, and there's a key point, 3 pi over 4 comma 1. Well, if you look at our graph paper, we don't really have that as a point. Oh, I got to back up a little bit. I'm going to go ahead and do a dotted horizontal line at 2 to kind of indicate where that line of oscillation or midline would be. Okay, so back to what I was saying. That key point, 3 pi over 4 comma 1, well, 3/4 pi is halfway between a half pi and a whole pi. So that would be right there. So 3/4 pi comma 1 is here. We go to look at the y-intercept 0, 2.7. 2.7 is right about here. So we can kind of guess that the graph is going to start like this. Now the next key point is 7 pi over 4. Well, 3 pi over 2, if you double that, double the numerator and denominator, that's 6 pi over 4. And 2 pi, if you double, quadruple, that'd be 8 pi over 4. So this halfway in between is going to be our 7 pi over 4. So we know we've got a point right here. Split the difference, and we get this. And then you realize that every 2 marks is kind of an important point. And then there's our graph. So there you kind of develop a little knack, a little skill at translating the graph from the screen to your paper. Obviously, when you tap the screen and you get those key points, it helps. But if they're not explicitly written out here, 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 you might have to do a little figuring to see exactly where they go. So anyway, there's number 10. Number 12, the vertical shift is simple. This time it's written in front of instead of after the function, and that's okay. That's not unusual. You'll see it done either way. The point is that it's a constant value. It's added or subtracted outside of these parentheses. That is your vertical shift. So we can bet that this wave is going to oscillate above and below this horizontal line here. Now all we need to do is get a picture of it that we can transfer over. So y equals -2 plus function cosine x is our theta plus pi over 6. Okay, so hopefully if I zoom in a little, you see that at -2, a horizontal line you can imagine splits through that wave. That's where it oscillates. We can start with a y-intercept, 0, -1.1. So that's somewhere around here. Oh, let me do this in blue, right around there. I see another key point there, 5 pi over 6, -3. Where on earth is 5 pi over 6 in relation to pi over 2 and pi, etc., etc.? Well, pi, 1 whole pi, you could think of as 6 pi over 6. Pi over 2, if you multiply the top and bottom by 3, 3 pi over 6. So 5 pi over 6 is going to be somewhere between 3 and 6, but a little closer to 6. So I would estimate, see if this is right here, somewhere around here to be 5 pi over 6, -3, we can put a dot there. And then somewhere halfway, we can get a crossover through that line of oscillation. Let's find another key point right here, 11 pi over 6. Well, okay, this one would be 2 pi would be the same thing as 12 pi over 6. 12 over 6 is 2. 11 pi over 6 is just a little smaller than that. So right around here, just ballpark, would be that maximum value. Split the difference right around here. We get our little crossover point. And then our next sort of critical value, key value, 18 pi over 6. Okay, that's 17 pi over 6. 3 is 18 pi over 6. So 17 is just a little bit less than that, maybe right around here. -3. Split the difference. We get the point where it crosses over the line of oscillation. And what we've just done is fudged it. Not perfect, ballpark, little arrowhead in each direction, but there it is. When you shift something to the left or to the right a fraction of pi, it gets really tricky. So I'm kind of letting the cat out of the bag a little bit. The number that you add or subtract inside the parentheses creates your horizontal or phase shift left or right. So you take a wave and shift it pi over 6 units in some random direction, and the graph gets a little more complicated to draw. So just do your best. If you look at number 14, based on what I just told you and what we've been learning, so +1 is going to have to be its vertical shift. It's not in parentheses with theta. There is no other number in parentheses with theta, so I do not expect this one to have a horizontal or phase shift whatsoever. It just shouldn't be there. So let me do two things. Let me graph y equals sine x. That's a normal sine graph with nothing messed around. And then y equals sine x, then outside parentheses +1. And there you see just the normal sine wave shifted up 1 unit. So I can draw a little dotted line here. And then I can put in some key points. So here, pi over 2 comma 1, 3 pi over 2 comma 0. Halfway in between is where it's going to cross over that line of oscillation. 5 pi over 2, halfway in between, it's going to cross over. About that far away, it goes down like that. And so there's my graph. And that number 14, that's the last one. So you're going to do the odds. Amplitude, easy. Period length, formula. Oh, I'm fighting back a sneeze. Sorry, guys. Amplitude, easy. Period length, formula. Use my examples to work those out. No graphing required. 7 through 13, vertical shift, if there is one, easy. Should be pretty easy. Phase shift, we're not going to worry about till after spring break as far as finding the exact phase shift. But sketching your graph, however it may look, I just want you to do your best to transfer from Desmos to paper. Good luck. As always, email or comment if you have questions. And if I don't talk to you again, have a great spring break.